Okay, we are going to talk about the collision theory, which explains why increasing concentration, temperature, surface area, why increasing those things, why will that increase the rate of reaction? Right, so it's a fairly simple idea, is that in order for, actually we have two reactants, let's say we've got A and B, which are going to react to form C. In order for them to react, they've got to collide with each other. So I'll draw the particles of A as like red dots, and the particles of B as blue dots, and they've got to bump into each other before they can possibly react. Okay, so let's think about this beaker here on the left. Okay, so here we've got a low concentration of both the red and the blue, and all those molecules, I've drawn these little ticks on them to show that they're just flying around constantly in a random sort of way. What I haven't drawn there is the water molecules or the solvent molecules, because that would just make it look confusing. But you can see in order for them to react, they've got to collide with each other. And when you've got this one at higher concentration here, there's more particles in the same volume, and so they're more likely to bump into each other. So the rate of reaction is going to be faster. So that is fairly straightforward. Let's have a think about surface area. Okay, so here, let's, for example, we've got some the green bits of magnesium. That's magnesium metal. I'm going to react them with hydrochloric acid. It's actually going to react with the H+ ions in the acid. So the magnesium is the green stuff, and the H+ ions, I'll do them as little red dots. In order for them to react, they've got to collide with the surface. Now we can see on the left, when we've got one big bit of magnesium, it can only, the surface is just that black there. If you break that big bit up into 4 smaller bits, then not only have you still got the surface area, the black that was there, but we've got all this new surface, which I'll do that in blue. All this new surface is being exposed for the hydrogen ions to collide with that. So the rate of reaction is going to be faster. So if you have a smaller particle size, you're going to have a bigger surface area. The rate of reaction is going to be faster. So that's quite easy to explain that. All right, let's now think about temperature, which is a little bit more complicated. Okay, so I've got this A and B again. Now, say that is a low temperature. The average speed of the molecules is quite low. So if we increase the temperature, the particles are going to move faster. That means they're going to cover more ground, and so they're going to collide more frequently. But that is not the full story. That is not, doesn't explain everything about temperature, because when two particles collide, so here's our A and here's our B, when they collide with each other, they don't always react. Sometimes the collisions are unsuccessful, and the collisions will be unsuccessful if the energy of the collision is too small. So if there's not enough kinetic energy in that collision, they just bounce off each other. Okay, so what this minimum amount of energy required for a collision, this is called the activation energy. Okay, so that's the minimum amount of energy in the collision is required for the particles to successfully react. If they don't have that, they just bounce off each other. Now, if you increase the temperature, you make the particles move faster. So what that does is it increases the kinetic energy of each collision. So that means on average, more collisions are going to be successful. So not only do you get more collisions, but the proportion of them which are successful also increases with temperature. So that's why temperature has quite a big effect on the rate of reaction. And usually it's not always true, but it's a rough rule of thumb. If you increase the temperature by 10 degrees C, you'll double the rate of reaction. Okay, now the next thing we need to think about is how do catalysts speed up rate of reaction? Okay, so right, the way a catalyst works is it provides an alternative route for the reaction, and that alternative route has a lower activation energy. So if the activation energy is lower, the proportion of collisions which are successful will increase. That means the rate of reaction is going to go faster. So let's just summarize all that information on the collision theory here. So we've got this table here, right? Let's rub this out. Right. So we are, for each of the things we're going to do, we're going to increase concentration, increase surface area, increase temperature, or use a catalyst. We're going to look at what will that do to the frequency of collisions, and also what will it do to the percentage of collisions which are successful. Right, so if we, first of all, let's think about increasing concentration. Okay, now if you increase the concentration, you will just increase the frequency of collisions. Okay, you don't increase the speed of the molecules or the kinetic energy of the molecules, but there's more of them in a smaller volume, so they're more likely to collide. But the percentage of the collisions which are successful, that is unchanged. Okay, it will be the same. If you increase the concentration, you haven't changed the energy of the particles, so it's the same proportion of collisions which are going to be successful, but the rate of reaction will increase because you've got more collisions overall. Let's think about surface area. That does a very similar thing to concentration. You just expose more area, so you get more collisions. But the energy of those collisions is unchanged, and so the percentage which are successful, that is also unchanged. Temperature, well, we've seen that you make the particles move around faster, so they're more likely to collide, so you get more collisions. And also, when they do collide, the percentages in which are successful will also go up, because they've got more kinetic energy. They're more likely to have energy greater than the activation energy, the minimum energy which is required for them to react. Now, if you use a catalyst, you don't do anything to the frequency of no effect to the frequency of the collisions, but you will make, because you've lowered the activation energy, more of those collisions have necessary the minimum energy to react, so that the proportion of successful collisions will go up. Okay, so that's all you need to know about the collision theory. A typical question, this might be like a 3 or 4 mark question on explain why increasing the temperature will increase the rate of reaction. If they're just asking about concentration, there's not so much to talk about there. It might be just a 2 mark question.